Okay, I chose question 3C, as I noted up in the corner. Today we're going to be working on this question. We're going to break it up into two parts since there are two questions, but let's read it first. A spherical balloon is inflated with helium at the rate of 100 pi feet cubed a minute. How fast is the balloon's radius increasing at the instant the radius is 5 feet? So let's stop right there. That's the first question. So first thing we're going to do is find the given values. This is easy. This is right in the question. So, given values. We have the change in volume in respect to time right here. So, delta volume over delta time. Delta is just Greek for change. So, change in... Oh, oops. I wrote volume twice. I definitely meant time. Change in volume over change in time. Since I'm more used to physics, I do it with the triangle way, so I'm just going to do it the triangle way. Delta V over delta T. Okay, not off to a good start. This is 100 pi feet cubed a minute. And we also have the radius at the moment that we're trying to find, which is 5 feet. So now, second thing we do, we see what equation we're going to use and then differentiate that equation. So, differentiate. Equation we're going to find for a spherical balloon, the volume of a spherical balloon. So, that would be 4/3 pi radius cubed. Cubed because it's a sphere, it's three-dimensional, not two-dimensional. So, volume equals. Yep, so we got the equation. To differentiate, we're going to use the power rule. Let me write that down. Power rule. Which means we're going to subtract 1 from the power rule up here. So it is now going to be 2. But we take the original 3 and we plop it right there in the front. So it's going to be 3 times 4/3 pi radius squared because we subtracted. Since there are two 3's, they cancel out. So now we have 4 pi radius squared. That's correct? I think that's correct. Now we're going to plug in the values. So remember we started off with dv dt. So change in velocity, change in time equals 100 pi equals 4 pi radius, which is 5 squared. So now we're going to solve. Oh, but hold on. You gotta add the delta radius, delta time, because that is what we're gonna try and find. We're gonna find the change in radius over the change in time. Now we start with what's in parentheses. So 5 squared, 25, times 4 pi, which equals 100 pi delta radius, delta time, and we bring this down. So now we have 100 pi equals 100 pi, and then this thing. Now we divide 100 pi from both sides, and we get 1 equals our change in radius over change in time. But it's not just 1, you got to remember our units. It is 1 feet a minute, which is our answer right there. So we answered the first question. Now on to the second question. How fast is the surface area increasing? Shoot, this is already 5 minutes long. Okay, how fast is the surface area increasing? We go back to number 2, we find our equation and differentiate. Now we're finding the surface area. So the surface area is, for a sphere, is surface area is 4 pi radius squared. So to differentiate, we're using power rule again. Bring that 2 up front, minus 1. So it's going to be 8 pi radius to the first. We don't have to do anything to it. Now we plug in our numbers. We know that radius is 5 pi 8. Oh, and we also have to multiply it to change in radius over change in time, which is 1, so we don't really have to add it, but I'm just doing that there for math purposes. So 5 times 8, 40. Bring the pi down, pi. So our answers officially: how fast is the balloon's radius increasing at the instant the radius is 5 feet? Well, it's increasing 1 foot a minute. And how fast is the surface area increasing? Well, it is increasing 40 pi feet squared a minute, because we got to remember this is 5 feet radius and this is and this is 1 foot radius, so feet squared. These are our answers.